Welcome and hello everyone. I'm Darren McHugh, the product manager for the Icon 2. We have some really exciting new developments to share with you here at InnoPharma Technology. We're going to showcase a significant upgrade in our image analysis software, EyePASS. This is going to be revolutionary for our Icon 2 technology. So after we cover some theory and background about the new image analysis upgrade, we'll go to a live demonstration of this new technology in action. This slide here, I guess, is for those who are unfamiliar with the Icon 2. It's just a condensed depiction of what the Icon 2 can be used for. It's targeted for the inline powder and bulk solid processing market, where the one device can be used in an analytical lab, a pilot plant, a continuous production environment. It's smart, it's automated, it's rugged, and it's industrial. It ticks all the boxes for compliance in your environments. If we move on to the mode of operation of the Icon 2, it's a non-product contact real-time device that uses flash imaging, as shown here. This is where we go from, let's say, the hardware to grab the image and capture it and move it to the software for image analysis. On the right, we can see a raw image taken from the Icon 2, and it's illuminated with our red, green, and blue LEDs, and this is unique for showing up the foreground and background of images. If we move on to image analysis and traditional image analysis, the image processing can be defined as the technical analysis of an image using complex algorithms. The image is the input, and the useful information returned is considered the output. And sometimes we call this feature extraction. In our case, this is particle size. So we're pulling out the features of particle size from these images. Traditional vision systems take a set of well-defined functions in a sequence to solve the problem. One of the primary steps performed by the Icon 2 image analysis software is particle segmentation. This is the detection of the edges of particles, so we can then match volume to them and pull out things like PSD, particle size distribution. So this is traditional computer image analysis, showing it in a flow diagram on the left. And then if we move on to EyePASS version 3.0, our new release that we're going to be showcasing today, it's using convolutional neural networks, and that's actually AI technology. So what we've done here is we've injected machine learning into the EyePASS flow for image analysis, and this is opening up whole new capabilities for us in terms of new markets, new materials that can be measured for particle size distribution. So the convolutional neural network is used to better segment what the icon sees. The artificial intelligence into EyePASS is using the cutting edge of machine learning techniques to drastically improve the ability to detect and measure particles, enhance the segmentation, which means a wider range of materials can be detected. But a little bit more then about AI and machine learning and how we're using it. So AI is a very broad and encompassing term. I don't believe we have the time to cover all the nuances of what it means today, but I think it's fair to say that it draws different cognitions for different people. When we talk about AI, what we mean is artificial intelligence is a simulation of human process intelligence by machines or computers. So essentially, AI is mimicking an operation that an operator might do. And in our case, that's for vision systems. We're going to cover in the coming slides how AI is injected into Icon 2, but it's fair to say we're using AI to give Icon and EyePASS the competitive advantage. So a little bit about machine learning. Here we have a generic model of how a vision system could be used. So if we take images of, let's say, cats or dogs and birds, and we label them that it's a cat and a dog, with supervised learning, we can then build a predictive model. And what that really means is the next time our machine learning system comes across a dog in the real world, for example, it can then return the variable that it's seen a dog. If we apply that a little closer then to what we're trying to do in terms of particle size analysis, we take raw images from the Icon 2, we label them with our supervised learning process first, and the next time the model sees them in the wild, like in an inline process, for example, it can then return the particle size distribution for those images. So if we talk a little bit about machine learning and that validation process and how we build these models, again, this is more of just a generic flow of how that works behind the scenes. But we take a set of training data, we manually annotate that data for the segmentation process, we build a predictive model, we take new unseen test data, we put it past the predictive model, and we measure the output, and we evaluate how well it's doing in terms of image analysis and particle size distribution. And this is done the standard way any particle sizing would be done. It's compared to known standards and a measured result. But the great thing about machine learning is it's more flexible in terms of it can be iterated. We don't have the traditional algorithm method of image analysis that's fixed. So this means that we can continuously improve the model. But that's to say, after we roll out a predictive model, it's a locked algorithm. So what happens behind the scenes when we're doing this evaluation of our machine learning models? We use a thing called Kfold Crossvalidation. And this is a statistical method used to estimate the skill of the machine learning models. Data splitting process can be done more effectively with this Kfold validation method. And the splitting process is done without replacement. So each observation that is used for training and validation is only done exactly once. So that's all that happens in the back end of EyePASS version 3.0, but the same user-friendly, easy-to-operate software EyePASS is there for the user. The only thing that we'll see in the difference is a slight difference in the configuration setup for version 2 software to version 3. But the great thing as well is we do include the version 2 algorithm in all version 3 softwares. So if someone wants to use the traditional image analysis method, they still can. Maybe they have a validated system and they don't want to move on to the machine learning method, but EyePASS 3.0 will have both methods included. So, what does this really mean then? This slide here depicts what EyePASS version 2 would have been brilliant at for measuring for particle size. Because of its direct illumination, it was well suited to bulk solids between the size range of 50 microns and 5,500 microns that were typically of a white, off-white nature. And that's because of the illumination. Materials that would have been out of bounds with version 2.0 and before were materials that were either highly reflective or slightly crystalline or had a shiny properties. Thankfully, with version 3 and using these machine learning methods, we can now actually extend the amount of materials we can measure with the EyePASS system. So we can measure materials that are either of a dark body or are shiny or crystalline or slightly see-through. Materials that would still be considered out of bounds or not measurable by our particle sizing system will be materials that don't flow, and that's the white material shown here. So think of something like flour. It's not going to get any degree of separation when it's flowing. You can't measure it. And also materials that are outside the measuring capability of the instrument, such as materials of a pellet shape, where they can present either end-on, like a circle to the camera, or side-on, like a rectangle to the camera. Using the elliptical method in the background, it's not suitable for these types of materials. Okay, so that's enough about the theory and the background of the Icon 2 and the new machine learning version. Next, we're going to move over to actually a demo here in our process lab showing this software operating. But let's just give a quick recap of the actual hardware. So this is the Icon 2 here. Essentially, inside here, we have the industrial camera, our ring of LEDs in the bottom. It's all GMP compliant. It's ATEX rated, IP65, all these good things for your environments. We have it mounted here on our analytical automated stage. So this makes it a benchtop unit in this configuration. And then we have the green communication cable here running back to our connections hub, which then runs back to the laptop here with our software EyePASS that does all the heavy lifting for image analysis. So underneath the camera system at the moment, we've put some known standards, some sieve standards. Essentially, these are glass beads that have been put underneath the Icon 2. And as you can imagine, they're being made of glass. They're highly reflective, highly see-through, typically material that would not be measurable with version 2 and before. So if we actually jump over to the software, we can show you what that looks like. Here we can see the session setup window. Underneath the Icon 2, we have the glass beads, and we can see the reflection of the red, green, and blue LEDs back into the camera. And the great thing about the machine learning version of EyePASS is we can tell it to ignore these features because we're not interested in them. We only want to detect the edges of these glass beads so we can work out particle size. Let's start a session quickly. So if I give it a unique identifier, we select a config from the dropdown that will apply the illumination and focus settings that we've decided for this material. And then we can actually start recording. So we'll be taken from the session setup window over to the live measurement window. With the automated sample presentation stage, that will communicate with the EyePASS software, and the EyePASS software will communicate with the Icon 2 to grab images. So they're all in sync with each other. What's happening now is the stage is moving underneath the icon to present a new image for the camera system to grab for static image analysis. And it's worth pointing out that this is all automated and hands-free and digitally recorded. So while we wait for the first image to get processed and come back to us as a size distribution, let's have a quick look around the screen. You can see here we're set to the volumetric measurement. We can switch to the numeric. We can also add our session comments. And as the first image comes in, we can see down here in our histogram and our S-curve that from one image so far, that the particle size range, or 44% of what we measured so far, is within 903 and 1021. And that's already been updated as the next image comes in. So this has been added cumulatively together, so we get our full particle size distribution. And this will do 27 movements, so it captures a unique image of the tray, and we never get the same image twice, and it takes roughly about 10 minutes to do a full tray. But again, all automated and hands-free. We won't do the full 27 positions today. It's really just to show that it's still the same user-friendly software EyePASS that the operator will see, but now we have machine learning running in the background for that image analysis and being able to measure materials that are now translucent or reflective or shiny or necessarily not an off-white body. We now have that capability. But to talk about that a little bit more, we'll move back to the slide deck over here, and we'll talk about what's happening in the background for this image analysis and what it really means for the Icon 2 and EyePASS version 3.0. So, the then and now. The top left image that you're looking at here is a raw image taken from the Icon 2. It's these glass beads again, these sieve standards that are used to measure, or we're using to measure for particle size. With version 2 of the software, because of the high reflection, the image segmentation would have been inadequate. We would have got a lot of false positives. But with machine learning added, telling it to ignore all those reflections and only focus on the edges of the particles that we're interested in, you can see a much more improved accuracy or segmentation of these images. So that's really what we're showing here today. And because of this new capability now, we're able to actually open up new materials or even new markets for the Icon 2. We're no longer purely pharmaceutical material focused. We can measure dark bodies or reflective bodies or materials that are really being shown here. We're still targeting an inline processes because that's where we see the most value for our customers for this piece of technology, measuring right where your bulk solids are being modified so you can make decisions then about either improving your product via things like increasing yield and get that real-time data that you need. So we hope you take away from this that the Icon 2 has so much more added capability to it. Just to show some of the unique points about the Icon 2, here we can say that it's been used for basically a lot more industries and processes now than it was before. We're essentially using Industry 4.0 technology in the form of AI and machine learning today. It's developed, it's ready, it's not a promise of tomorrow. And it's also much more suitable for marrying physical production with smart technologies. And here, I guess we're specifically referencing things like Industry 4.0 with the capability of IIoT, Industrial Internet of Things. Also, we're seeing that we're using leading-edge hardware and software combined now with the cutting-edge AI on the market. I hope you've actually found this useful, and I hope there's some takeaway points from this that you can use for your industry. But please feel free to contact us with any of your questions. We're happy to support, and we're really looking forward to your feedback and getting this rolled out into the field. Thank you very much.